So Susan, when you go into a food facility, where do you see people sampling and where should they be sampling?
Yeah, awesome question. I typically see people sampling post-cooler. So in this example, so before it goes into a package, that's typically where their CCPs are for a product. So we'll see a lot of heavy sampling in that area and then some sporadic within the process. I've got some clients that are really starting to understand the variance in ingredients and how that affects the dough. So in this cookie example that we're showing, we've got a dough area where we're doing the mixing of those raw ingredients. We've got an oven, and then we've got a cooler. So understanding the mixer, so dough is typically 0.99, pretty close to what you'd see for water. And then at that cooler for a cookie to get that nice crunch that you might want, that's about 0.3 water activity. So by getting those two areas, that gives you one view, but the part that's missing is the most important part and the part that takes the most energy to run, and that's the oven. So what I love to see is clients that are branching out and really understanding a target for each process. So dough is one process, the oven is one process, and then cooling. And then we could expand this also and look at how you're storing after you cool it before it goes into the package. So depending on where you're at 0.3 water activity, if you've got a really dry environment, you could lose moisture, versus in a humid environment, you might actually gain moisture and push this above where you've got some gross cookies that aren't crunchy. So understanding each of these processes, I think, is really important.
And I think something that's actually missing from this graphic is that I notice a lot more companies measuring incoming ingredients. So a lot of companies now will set a spec, maybe plus or minus 10% for water activity of incoming ingredients. And the reason for that is that any variation in your incoming ingredient can be carried through to that final product. So I think that's becoming more and more common. Have you seen that in your experience with some companies?
Yeah. One of my favorite, that's why I'm over here smiling. One of my favorite clients is Sunrise Fresh, and they have a family farm. It's just awesome. So they're growing cherries, walnuts, and things like that. One of their products that is most troublesome is the cherry. From year to year, and I didn't even think about this, but from year to year, depending on the amount of water and sunshine that cherry is getting, changes the Brix level of that cherry. So now they're coming in and looking at that cherry and doing an isotherm on it to understand how that change in Brix affects that cherry. And if you're just putting a cherry drying it and putting it in a bag to munch on, that's one thing. But if you're using that cherry as an ingredient in another product, like an energy bar, for example, then it has a bigger impact because sugar is such a strong humectant. So that's a fun way to look at ingredients. A small change from year to year variation in cherry can be a big change in a granola bar.
And I think it is important to note that we can make an isotherm, whether it's every season or every formulation. That isotherm really helps us to pinpoint the sweet spot, kind of going back to our previous mistake. And again, we can make that isotherm for every product or formulation and then use that information to set the target correctly. Something else that I think that we could note about this figure is that I do notice some companies using benchtop water activity meters to try to get an in-process measurement, and it can be somewhat effective. But if you are pulling a sample and if you're having to wait for the temperature to come to the right temperature, or if you're having to do a lot of sample preparation, even if you're taking a 1-minute reading on the Aqualab 3, it might be taking you 20 plus minutes in order to get a reading. And by that time point, it's already too late, that the changes have already happened and you can't correct effectively. So why is it so important to be able to take an in-process measurement?
Yeah, exactly what you're talking about. If we don't know, ignorance is bliss. We just keep running, and we're running product that is maybe out of spec. Maybe it hits your spec for a CCP, but it doesn't have the quality that you want. So by understanding exactly where you're at and quickly getting that feedback and making these micro adjustments is perfect, and that's where you want to be. And I think 20 minutes is too long. We're running belts because we've got these industrial dryers. We're running belt speed at as high as we can go because we want that throughput. So 20 minutes can be a huge amount of diversion and rework. I like to see this instant, and if you can close that loop, even better.